Graphing linear equations. Our lesson today, we are going to involve many lessons together. The linear equations that we took with the coordinates that we learned in the previous class. Okay, I'm going to start. This is a reminder how we used to fill into these tables. We have an equation for x and y values and how we find the values of y. Okay, let's start with the first one. When x equals negative 3, okay, y when x equals negative 3, then y will be equal, I'm going to substitute negative 3 in the place of x, then y equals negative 3 plus 2, the answer is negative 1. So the answer for y when x equals negative 3 is negative 1. Okay, 3. When x equals 3, then y, instead of x here, I'm going to substitute the value of it with 3, then 3 here plus 2 equals 5. So I have to fill into the value of y here, 5 when x equals 3. Now when x equals 6, when x equals 6, then y equals, instead of x I'm going to put 6 plus 2 equals 8. Okay guys, using these x values and the y values, each one of these are making pair of coordinates. Okay, so remember the way that we write down the coordinates of a point on xy axis. For the first point, let's name this point number 1, point number 2, 3, 4, 5. So point number 1, in place of axis here for the coordinates, it's going to be negative 6. The value of y is going to be negative 4, 2, 3, 4, 5, and 6. Okay, point 2 is going to be, in the x's you're going to write down negative 3, in the y's you are going to write negative 1, 0 for x's, 2 for the y, 3 for x's, 5 for the y. This is the fourth point. Sorry, there is no sixth point. The fifth point is 6 for x's and 8 for y's. So all the values of x's comes in the front, those, and with the y coordinates in the second part to make one whole point. So this is negative 2, negative 4. This is point on coordinates. I'm going to reveal this part. I hid it before. Okay. Now, let's plot these points on these coordinates. This is the x-axis, y-axis, positive, negative, positive, negative, negative. Remember, first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, the first point is negative 6 for x's and negative 4 for the y. Okay, so here is the first point, negative 6 on the x's, negative 4 on the y's, negative 4 on the y's here. So both points will meet right up here. This is point number 1. Point number 2, negative 3, with -1 for the y's. This is 0.2. 0.3, 0 for x's. Here is in the origin. And 2 for the y's. It comes directly here on the y-axis. This is point number 3. Point number 4, 3, 5, 3, 5. Point number 5 is 6, 8. This is 6. Here is 8. Now you have to connect these dots together. Let me bring my ruler. Now you have to connect these dots exactly where they meet the coordinates together. Okay, you have to fix the pen first, but then after that fix the ruler to match all of these points and then connect. As you see, my students, there is a line connecting all of these points, all of these coordinates, right? That's why, such as these examples, they are called linear equation, because after you connect all the dots, they all connected in one line. I'm gonna show you another trick in my next slide, how you can find the line by using only 2 points. Okay? Here's the next one. When x equals -3, we have to substitute the value of x here in this linear equation. So, when x equals -3, then y equals, remember the relationship between the coefficient and the variable is to multiply each other. So 3, I open a bracket, times -3 plus 1 equals, I like to put them underneath. 3 times -3 equals -9 plus 1, which equals -8. So our first coordinates is when x equals -3, then y equals -8. I'm going to try with x equals 0. X equals 0. When x equals 0, then y equals, instead of x, you are going to substitute it with 0. 3 times x plus 1 equals, 3 times 0 equals 0 plus 1, then the answer equals 1. Okay, I'm going to put these first two coordinates. So this is -3, -8, and the 0 is 0, 1. I'm going to plot these here on the coordinates. -3, -8. Here is -3, and here is -8. The second point is 0, 1. Now connect these dots. Be precise and be accurate by drawing the line. Now, from using this line, you can find the y coordinates, such as when x equals -1. Here is x equals -1. Go directly to the line. It touches the line right here on this point. That means then the coordinates of y equals -2. Let's try it out. When x equals -1, then y equals 3 times what the value of x is, -1 plus 1 equals 3 times -1 equals -3 plus 1, which equals -2. That's what we have seen here in this point. Okay, let's try point 1. When x equals 1, go towards the line. When x equals 1, go towards the line. So it matches here. So the coordinates for this point on this line and for y-axis is going to be 4. These points are meeting here. So the coordinates of y when x equals 1 equals 4. Let's check this out. When x equals 1, y equals 3 times 1 plus 1 equals 3 plus 1 equals 4. Yes, it is correct. The last point is 2. On the x-axis, just go and try to touch the line here so it crosses this point. Look at the y-axis. The point is 7. So when I give you a question, I'm trying to solve it at home. You can just find accurately, please, find the coordinates of y, plot these 2 points and connect them with a straight line. You are going to find the values of the missing y's. Okay? Okay, another one. Those 2 cases that I'm going to put in front of you are different because the value for one coordinates is fixed. In this example, the linear equation says y equals -8. That means no matter the value of x, always the value of y is going to be -8. Again, when y equals -8, that means no matter what is the value of x, such as -8 or let's say 0, 1, -4. No matter what is the value of x, the value of y is going to be -8. Okay, let's plot these coordinates on this xy axis. I'm gonna find them before we start plotting them. So the first point is -8, -8, 0, -8, 1, -8, -4, -8. It's okay if I put a negative value here. And 8, 8. Let's plot these points and connect them together on this xy axis. Okay, so -8, -8. Here is -8. Go down here. This is -8. First point, 0, -8. 1, -8. -4, -8. -4, -8. 8, -8. Look at these points. When you connect them, you are going to see that this line is parallel to the xy axis. So, as a conclusion, y equals -8 is parallel to the x-axis, guys. Another conclusion, any linear equation, when the value is fixed for y, always the line is going to be parallel to the x-axis. I'm going to give you another condition, another example. In this case, the values of y is different, but look, all the values of x must be 5. So no matter what is the value of y, the value of x must stay fixed for all these points, which equals 5. So 5, 5, 5, 5. Okay, first point is 5, -6, 5, -3, 5, 0, 5, 3, 5, 6. Okay, all the values of x is going to be 5. Okay, 5, negative 6, 5, negative 6. 5, negative 3, 5, negative 3. Can you see? Can you see now? They are above each other. 5, 0. Here's 5 and 0, y. 5, 3, 5, 3, 5, 6. So all the points come vertically. When we connect them to each other, you're gonna see that this equation, when the values of x are fixed, that means x equals 5, x equals 5 is parallel to what line? To the what? It's parallel to the y axis.